Hello and welcome to episode 4 of our tutorial series, where we'll be making a DirectX ready game engine. In this episode we're going to be building ourselves up a logger class, which will allow us to communicate freely with our program. We will also be looking into where exactly on our system we'd like to save this type of data. To be able to achieve all this, we will need to start to build ourselves up a library of common classes and functions that we can utilise in both our engine and our future projects. As well as our common utilities, we will be building ourselves a static set of per game settings. This will give us the ability to feed into our engine certain information at runtime, such as the project name or the icon. All of this together will leave us with a much more durable engine and a project with a little more character. And with all that being said, let's get into it. To start this episode, I've opened our solution from our episode 4 folder. Throughout this episode, we're going to be focusing on creating our logger class. This is important because the number one rule of programming is that we need a clear and easy way to communicate with our program. It's much easier when the program itself can tell us what's wrong with it or what's happening, instead of us needing to rely on actually looking at the code itself. Now, Visual Studio already gives us a couple of ways to be able to communicate with the program itself, and we're already using one in form of the message box. We've seen before that this will pop up a message box onto the screen and it will print out information for us. This can become quite intrusive. We wouldn't want to have to keep using this and have to keep quitting out of these boxes. Another way is the output debug string. If I was to run this now, you would actually get a debug string printed out into the output box down here. It's very much less intrusive and it's very much more subtle, but sometimes this can become too subtle and the information can be lost in a string of lots of information from the system. So the way that this is normally done is a different separate class is created as a logger class. And what we are now going to do is create this class to be able to save that log file directly onto our hard drive. And that way we can just read off the information from the system, and if for any reason we wanted to come back to it later, we could get that information directly without having to run the code again. Trust me, this is very beneficial if you're becoming frustrated that your code is not working properly. Now, before we run off and start building our logger class, I want to mention the second rule, in my opinion, of programming. And I've actually just broken it by trying to teach this example. At this stage, I have added the output debug string to our code. And this is fine, it won't make an amazing amount of a difference. But I never tested to see if this was working before I started making changes to it. At this stage, I'm pretty confident that this program is going to work. It was working in the last episode and I see no reason why it shouldn't be working now. I'm pretty confident. If I was to go off and start building our logger class now and everything was going on as it should be, and then I suddenly found that the program wasn't working, my confidence that this was working in the very beginning will start to waver. So the second rule of programming is that you should always test your base code before trying to make any changes. So let's just get rid of the output debug string here and let's just run our program. Let's just let that compile, and that seems to be working absolutely fine. Now as I continue, I can confirm 100% that I know that this is working. Now that we've tested our code, we can actually move on to creating our logger class. So let's go up to our switch views, come to our folder view, come to our episode 4 folder, and let's come to our Olympus folder. this is going to be a class that is going to be available to every single program that we make, and therefore it needs to go in our game engine and not in our game. Let's go to our source folder. Currently we have our platform folder. That is for our Windows platforms, but that's not where we're going to be putting our logger class. Our logger class is really a very common thing for us to be using. This is a common program. So let's create ourselves a common folder. As standard, we want to create our two files. Let's put a logger.h in here and a logger.cpp. Perfect. Let's now go back to our solution view, and we can now import these into our public and our private folders. We're going to create the filter for this. And let's just click on add existing item, come to source, common, and just add those two files in here. We now have two new files to work with. Let's come up to our logger.cpp, and let's just add our include here. That needs to be Olympus and our logger file. Now, one thing that I'd just like to point out here is if we come back to our Olympus file and we come here, if we look at this include file, we're going to see that we're still pointing to our episode 3 folder, but we're on episode 4. That's because when we set this up in the last episode, we set it to be a very specific route. We didn't make it generic. So let's go and change that now, so that we don't have to do this in every episode that we do. Let's come to our Olympus and let's come to properties. Let's come down to C++ and let's go to general, and we can see here that we've got Olympus episode 3 and then Olympus engine. We can actually come up here, select our solution directory macro, come back to general, and we can get rid of everything up to the point of Olympus engine. If we paste that in there, that will now work generically and correctly and migrate this every time we create a new folder. Let's just click OK on that. We're actually going to need to do this again with our blank project. Let's come up here. Let's just add blank project. And with blank project, we're going to have to do this twice because we've got this macro twice. If we just copy and paste that out there, that all should work absolutely fine. If I come back up here now and come up to Olympus, this is now pointing to our episode 4 folder, and this should be working absolutely fine. We can then move on to actually start to create our logger class itself. So I've just already put this together for us just to give us a start. We need to think about how exactly we want this class to function. We could have it that we might want to keep multiple different logs or multiple different instances of this logger class and create them for every different class we create. That's an option, but it's not one that I prefer. What I like is to have one single logger class for our entire program. I then like to be able to access that from anywhere in our program with one simple command and be able to then print the screen. To do that, we need to create a singleton class or a static class. To do this, we need to create a static instance of the class itself. I've created this as a declaration for this class, and I've just created this just so that we can return that, and that's been created as a public. That gives us access to this class if we want it. Because we've created this in our header file, we need to come back to our logger.cpp file, and we need to actually create the namespace version of this variable. Let's just put this in here like so, and just put the namespace in here. That means it's declared correctly. We haven't created these in here, so let's just do that now. This is round the wrong way. Let's quick create this one, and let's quick create this one. Now to make this into a singleton class, we need to initiate this instance class. So let's just go instance equals this in our logger constructor. That means that the very first time this is created, it will make this into the singleton or static class. Anytime we try and reference that class again in the future, even if we were to try and recreate it, it would always just point us back to this one instance of this class. So what this gives us the benefit of doing is just putting this in our winEntry function once, and we'll be able to access it wherever we want. To be able to access this class from wherever we want in the program, we need to be able to put this in our PCH files. If we do, however, put this in our PCH files, we need to follow a very slightly different methodology. And this is the best way I can explain this is this. Let's open up our Olympus.h file. It's already open here. If we put our logger.h file in here, and our logger.cpp file is already logging from here, and we were to put this in again, it would come up twice. It would be once in our PCH file and it would be once in this file, and this would cause us errors. So what if we want to put something globally available to our entire program? What we need to do is take it out of our CPP file and put it into our Olympus.h or our PCH files. This still gives us the same abilities, but that means that any of our programs that are connected to these PCH files now will be able to access our logger class. We will actually need to go up to our Olympus.h, and we just need to change this to common, because at the moment our logger.cpp file is fine reading it in our logger.h file on its own, but the rest of the functions and the rest of the classes won't be, so we will need to put the common prefix in there as well. If we now come up to our winEntry function, which also gives us the Olympus.h PCH, we can define the logger variable itself. This will create our actual logger function. Just create it up here before we put this. Now, these two words, this declaration of a logger, is all that we are going to need to be able to initiate this for the entire program. Now we've created this once and we've referenced it in our PCH files. This will work anywhere in the program. To make our logger class work, we're going to need one function to be able to print text to the screen. I've created this function to do this. It's a static void type function, and I've just called it PrintLog. We've put some inputs in here, and I've put this in the form of a W character pointer. Now, this is normal when we've put the first one in, but you may be able to see that I've got these extra 3 double dots afterwards. This means that our inputs can be a multiple of any amount of these W character pointers that we want. This is so that we can feed in extra information to our strings later. This sounds a little bit confusing, but I'll show you how it works. If we come into our logger.cpp file, we can just create this function here. Now, I've gone ahead and I've created some of this function already for us just to speed things up. To make this work, we're going to need to include the fstream header. Let's just add that in there as well. Now that that's here, we've got everything that we need to be able to print out to our log file when we have set up a log file. And we can do this with conditional or optional arguments. Now let's explain how this works. We've set up a buffer for our overall string to sit in. We've got a list of arguments that can be passed into that string. Now this will take all of the arguments from here and it will place them inside this primary string. It's easier if I just show you how this works. So let's just add a little message box in here. And let's just use the buff argument here. This PrintLog file will now work, or this function will work on its own. And we can test this out now. So let's come over to our blank project. Come to our source files. Let's come to our application file here. And we have got a message box in here that's saying I have loaded up. Now, we're going to need to come to our PCH files and we're just going to need to add in the logger file. It's going to be in our common files and logger. This means we'll be able to use it all the way through our blank project file now as well. Let's come back to our application class and let's just change this now to our new variable. So if we go logger, print log, we can now change this to be able to say I have loaded up. This is great. Now this is just using this function with one string. So first of all, let's just make sure we can get it working with just one string. Let's just run this quickly. This has built successfully. And it's asking us for us to transfer our DLL across. So let's do that now. Let's open up our Olympus Mons folder. Let's come to episode 4, go to Olympus Engine, and we want to come to our build folder here. And let's just grab our olympus.dll and let's just put that in our blank project. Let's replace that in there like so. And let's just try running that again. We can now see that our new function is giving us the same details as our message box. Now, this hasn't given us an amazing amount of abilities so far, but we are going to change this. This does, however, now give us an extra ability, however. Let's just say that we wanted to put the name of the program in here. We can just put a percentage and an S in here. We can then add a new string on top of here, and we can just add... Let's say that we wanted the name of the program, and this is going to be blank project. And just to make this really nice and easy to see, let's just add a thank you on the end there. Now what this is going to do is it's going to take this entire string, and this is going to be our base string. It's then going to read these types of characters. S is going to be for string, D is going to be for a number, an integer. And then it's going to input that as a string. So when we actually run this now, it will say, I have loaded up blank project. Thank you. Let's try that now. And there we go. We can see that working perfectly. That's good, but that's not really how we wanted it to work. So let's see if we can make this even more difficult. Let's go back to our logger class and let's start to think about exactly how and where we would like to save this off, this log file off to. There are a couple of different choices on where you can save a log file. One would be the solution directory directly, but once we build our project for release, that will disappear. The second will be the build file, and this is again a perfectly good choice, and a lot of people will use this file directly. There are, however, a couple of problems with building directly into the build file. First of all, you've got to understand that the build file was probably going to be the reference of C program files, and it could be locked, and we may need to get away with how to access that file from a locked system. The other problem is if we have multiple users that access the same PC, the log files will all get jumbled together, and we won't have any way of distinguishing what log file was for what user. Microsoft, however, gives us a specific folder for this reason, and that is the AppData folder. the AppData folder is specifically for applications to save individual things per user. So that's exactly where we should be putting this type of data. Later when we're making save games, they will also go in our AppData because they'll be individual to a specific user. Now I've made us a basic URL of what I think that we roughly need at the end of this file. This is an example file and location of what we're expecting. So as you can see, we're just going to AppData. If you don't know how to access your AppData file, just go to any folder explorer, go up to the top and just write AppData with the percentages like I've done here and hit enter. You'll be able to go to your AppData file like this. As standard, we are probably going to want our own folder for the project, and our project is currently called blank project, so we're just going to create a new folder in there called so. Because I like to be organized, I've just created a log file. Now, this is the rough description of how I would expect the log to be created. We would reference the log specifically on the name of the project. We would then reference the log on the actual date of today. That's the date of today, the 3rd of the 5th, 2021. We then reference the specific time that the application started. For example, that would be the 1940 and 56 seconds. And then we would need to create ourselves a specific type to read. Now, the specific type is not too much of a problem as long as we're always going to be using that same specific type. It will translate into text and it will translate out of text, so that's not a problem. However, getting from a simple output debug string up to saving all of this information in this structure is going to take us quite a few steps. So I suppose let's get started. The first thing we will need on this journey is a way to be able to save and read information directly from a file, for example a text document. We can do that with a WF stream, so let's add one of those in now. Just call that out file because that's the file that we're going to be outputting to. The out file has a function called open, and we can use that as such. If we just close that off as such like that, and we can close. This needs two variables to be placed into here. We need the file URL, and the other thing that we're going to need is we are going to need a way to recognize how we want that text file to be read. So in this case, that's going to be read as a standard iOS-based input-output based app. Let's just change that into one of these for now so that we can log that nicely. You always get times when Visual Studio just does not do what you want it to do. So this is nice and easy. We are now going to open our mythical URL and we're going to do it into the output file. That's easy. So what we want is a way to be able to translate this into this. We're going to throw this in as a string. So let's just add a W string as such. There we go. Now, first thing we're going to need is we're going to need this part of our URL. This is the log directory. So let's just add that in. We're then going to want the second part of our URL, and that's going to be that log file name. So let's add that in as well. Now, I haven't gone mad. I know that this is not actually giving us any specific information, but I'm just trying to give us a way to visualize what we're going to be adding in here. These are later going to need to equate to strings, so let's just add a little string in the middle to separate these, and let's make these into functions because we're actually going to want to call these. we now need to create two functions called log directory and log file. That's going to be great because once we've created those two functions, this entire line is going to work absolutely fine. How, however, do we get our log directory and log file name? For that, we're going to need to add in a few extra utilities to our program to make it function correctly. Creating our log directory function to be able to return the URL of our log directory is going to be rather boring, so I've just gone ahead and created that for us. This is a simple function called log directory, and it returns the W string. Let's just go ahead and create that in our header file. We can create that, and we want to make sure it's static so that it can be accessed by the rest of our static variables. Now if we come back in here, we can see this is coming up in red. That's because it recognizes this function of WString, but if we come back into our logger, as much as it's not giving us any grief here, it doesn't actually recognize WString. That's because we referenced that in our Olympus PCH file. And one of the drawbacks of referencing a file in the PCH file is that you can't therefore reference the PCH file, and this file is missing the string header, so we just need to add that in now. There we go. If we come back to our logger.cpp file now, that will all be in there correctly. Now let's have a look at what we're doing here. So we've got our path, and this is the overall path that we want to return. We've got our AppData local, and that's just to be able to reference in this function, which is going to return the path of our exact AppData folder. I've used the WCS copy and the WCS cat function to just copy that app data into the path and then just append these extra functions onto here. I've used the create directory function to actually create a folder for our path on that file path. I've then created a second folder called log, and we are returning that path. That means that as we are finding this file structure, if those files don't already exist, we're going to create them along the way. Now this is nice, this is going to get us everything here, but there is one elephant in the room, and that is the game name. And we have to ask ourselves now, how do we specifically get the name of the project from our project into our engine? We used to be able to reference information from our engine in our project, but now we're finding ourselves needing to do it the other way round. And to do this, we're going to set up a set of variables called per game settings. Now, before we get into our per game settings, I'd just like to reference that this function here is not showing a red squiggly line underneath on mine, and it may be on yours. And that is because I have actually added off screen the include shl object.h file. At the time of recording, I hadn't noticed that this has been done off screen, so I'm just adding this in as a caveat now, and that should make this function work correctly. To create our per game settings, the first things we're going to need to do is go to our switch views and just create the actual files themselves. Now if we come to the Olympus engine and come to our source folder, let's create a new folder, and we're going to call this core. This is where all of the core functions for our engine are going to be located. Again, let's just add in our per game settings files. Make sure we do that for both of them. And let's come back to our solution.view. We don't currently have our folders for our core file, so let's just add that in as well. You can see already that from such basic things we've already got a lot of files in here, and this is just going to get worse and worse as we go along, and this is why we always must make sure that we're as organized as possible. Let's just add the per game settings into here as such. We're going to make this into a singleton class as well, so let's have a look into doing this. Let's just include our Olympus file. We want to actually put this in our PCH file itself, so let's do that now. Let's go to our olympus.h file, and let's add that in here. That's core, and that's per game settings. There we go. That'll be ready for the rest of our program to use. Now we've done that, we can actually look into creating the class itself. The same as I did for our logger file, I've just created us a basic class to start from, and I've turned this into a singleton class. This returns the instance the same as we did in our loggers. Let's just add in the namespace for that. Just copy and paste the actual name here itself. We can just do this like that. It's always really easy to just make that into an instance. We do need to create these files down here as well. Let's just do that now. And the first thing we'll need to do is we'll need to make sure that our singleton class is created the first time it's referenced. So let's just do that now. Inst is equal to this. Because we've created this and because we want to make sure that we've got one copy available, let's come up to our win entry. Let's just put this in here. So per game settings should be declared before our logger class. And then we'll just say game settings. There we go, that should be available from there. If we come back to our per game settings file, we can start to think about exactly what we want to keep in this file. We're going to need a few variables that we can just keep adding to as we go along, but I've just chosen a few of them just to get us started. These are some per game private variables. So I've chosen the game name, a short name just to reference the game by, the main icon, and a variable for us to keep the time for when our program booted up. I've created a variable called max name string, and this is just to declare a specific length for our strings to be. So let's come up here and let's just put this in here as such. We're just going to say that define the max name string as 256. Again, this will just make it available for our whole program. Now we've got this available, then we can start to think about how we're going to feed this information into our program. Let's have a look. If we can come back to our iApplication class, we already have this initialize function. But we're going to want to add in a different type of function just to allow us to set up our per game settings. So let's just copy and paste this here. I'm putting this before the initialize because I actually want this to run before then. So set up per game settings, and then we can just say called to set up our per game settings. If we do this now, it means we need to come back to our application class from our blank project. We're going to actually need to make a copy of this and just make sure it's available. Otherwise our program won't run. Let's put that in there as such. We can then create that and that will be ready to use when we're ready. To make this work, we're going to need to know when to call it. So let's come back up to our win entry. And what we want to do is we want to initialize our per game settings before we initialize the program. So let's just do entry app, and that can call our setup per game settings. We know that that will now be done first. To make this correct, let's put our logger class underneath this because we shouldn't be using anything from our logger class until we have our per game settings set up. Because we've created strings for our per game settings, we are going to need to come into our initializer or our constructor and just put some basics in here just to get us started. We can't leave those blank, otherwise it could cause errors in the program later. We don't need to do this for our icon, so I've just done this for the game name, the short name and the boot time, and I've just initialized it with the string of undefined. Now that that's done, we can come back to our per game settings, and we need to find a way that we can reference what we want these to be. And I've created us a few getters and setters just to do this. At the moment I'm going to leave boot time available and not built. We're going to look at that in a moment. So let's just have a look at some of these getters and setters for the top 3 variables. I've made these as such. Our H instance reference is not actually coming up as well. Now, this was originally in our win main file, and we declared this up here. This is in our PCH file for our project, but we didn't actually declare it in our Olympus.h file, so let's just do that now. Let's put this down with our max name string down here as well. The objective is that we're going to be slowly removing everything from that win main file and putting it into more global files, so this is fine. If we come then back to our per game settings, this should work absolutely fine. Instead of taking a simple string for set game name, I've already referenced it to use the same functions that we used previously to load in information from our resources. This means instead of setting our per game name to blank project directly, we can set it to the resource that is powering our game name. Let's have a look how we're going to do this now. Let's come up to our application file, and this is the one specifically in our project. Because we need the information to come directly from our project and into the engine, we need to run this first before we do anything else. Let's just add these functions in here to declare as this should be. You may remember that we have our resources available up here, and these are what we created in the very first episode, possibly the second now. Let's come back up to our application class, and you can see I'm just using the per game settings just to set the game name, the short name and the icon that we set previously. These come directly from these here, set short name, set main name and set game name. You may notice that there's an extra one in here that we haven't actually defined, so let's go and do that now. Let's just double click on our .rc project. Now we actually have our resource.h file open, so we're going to need to close that one first and just try to open that again now. Let's come to our string table. We need a new string in here called short name, and our short name is just going to be BP, just short for blank project. If we save this off now and come back to our application class, this should be referencing correctly. Let's have a look to see why this isn't referencing correctly. Open this now. We have our IDS short name in there, and I think it probably is referencing correctly. It's just, there we go, it is referencing correctly. It's just taking a moment to do so. Now that we've set our game name into our per game settings, which are being referenced here, we can then go into our logger file and we can pull these per game settings directly from that file. So let's do that now. We can say per game settings game name. There we go. Now that will work absolutely fine. Let's try this quickly. Let's try this by creating a message box that's just going to print this out for us. So let's go log directory .c string. This is going to need to be converted, so let's do that. There we go. I'm just going to comment out the output file at the moment. And this means that every time we now use PrintLog, this will correctly show us the log directory. Let's just make sure that this is working. So let's build our blank project and let us build our Olympus files. Our blank project is still building. And let's just build our Olympus files. That has also built us correctly as well. As always, we're going to need to come up to our build files and copy it across our DLLs. There is a quicker way to do this, and I will be explaining this soon, but we can only explain one thing at a time. There we go. Now that that's in there, and we are already running our PrintLog file, this will no longer print out this file, but it will now print out our directory. So let's have a look. There we go. As we can see clearly, this is now giving us our AppData file, our roaming file, and then our blank project, and then our log. This is, for all intents and purposes, working correctly. If we come back to our logger class, we can have a look at creating our log file function as well, and I've just created as this to do this. Let's just create that in here. Again, we want to make this static so it can be accessed in any direction. This is a simple file. It just creates us a file name, it puts the name of the game in, it puts the boot time, and then it puts the apex on there of .log, and then it returns this file. That's great, and that's actually going to complete the last of the things that we need to make this function work correctly. The only thing that we haven't got in here is our boot time, and that is because we're going to need to create a new function or a new class to be able to manage timing in our game. This will be very handy later when we need things like timers, so it's good to get this started as early as possible. Let's get on with that now. As we're adding new functionality to the engine, we're going to need to create the new classes for that, or at least the new files. Let's come up to our common file and just add time.h and time.cpp. We can then come back to our solution view and add those into our project. This is actually going into the engine, but we won't need to add the filters in there as we've already got our common class. Let's do this, and let's just bring this down to common. I've got a dot missing from here. There we go. To speed this up, I've gone ahead and created us the entire time namespace. So this is our time namespace, and it's got three basic functions in here: get time, game date, and get date time string. Now, we want to be able to display this in two different formats. We want it to be displayed once in a very pretty format so that we can read it nicely, and another way in which we would like to be able to get it just as the singular numbers. So I've created these three functions for us. Now, we want this to be a singleton class and accessible from everywhere, so let's add this to our Olympus.h. Now that we've done that, we should see that there aren't no errors in here. So let's have a quick look to see how these functions work. They're rather simple. They use the ctime include just to pull in the time, and then we use a wstring stream to just be able to put the time into that string. Once we've done that, we have the time in a string, and we can just convert that into a wstring. If the boolean, which is asking us to strip the characters, is true, then we'll just strip the extra characters in here just to replace it with just numbers. As standard, I've made all of these false, so the only time we'll actually need to declare this is if we specifically want it stripped. Other than that, we can just normally just call getTime on its own. This works exactly the same for getDate, and exactly the same for getDateTimeString, and getDateTimeString just puts the two together. Now that we've got this, we can move into our per game settings, and we can start to look to build this up. Now, the first thing we're going to need to do is we're going to need a way to be able to draw in our boot time. So let's just do that here. This is going to be our getter. Let's have a look. That's because this is the wrong format. So let's just change that to a W character pointer. And we should be fine. So that returns our boot time. Now we're going to want to set it that instead of saying mBoot time, we need this to translate into a specific boot time. So we can just use our new time function for this. Let's just type time. We can just say getDateTimeString, and we just want to use the true function because we want to be able to strip it. Because this is coming back as a string, we're going to need to convert it into a W character pointer. That is done now, and our mBoot time has now been filled correctly. If we now also come back to our logger class, and we come down to our log file, we can see that this is now populating with our boot time as well. That means both our log directory and our log file are now working correctly, and we can just unmute this and find that this is working. To output a file or input information to a file, output file works in a specific way, and I've just created this for us. This is going to take the output file. We're going to make sure it's open and that everything here is fine. If it's not, we're going to print an error message saying that we're unable to open the log file. We're going to convert our buffer that we created before just into a string for ease of use. In our output file, we're going to add a new line in here, which is going to be first in brackets the datetime string. Please notice we haven't put true or false in here because this will default automatically to false. We can then add in the string that we're using for our log. We'll just then close the file, and I'm just putting an extra copy into our output debug string, just so that we can also see it on the screen if we're running it in Visual Studio. Now that this is created, we have everything that we need to make this log file work. The only thing left to do is to test it. To test this, we're going to need to come back to our application. Let's come back to our application here. We've got this here already. Now, let's build our entire project and let's just see what happens. We're going to need to swap our DLLs over, so let's do that as well. Now that that's built, we can just swap those over. So let's come to our Olympus, DLL, and blank project. Let's just paste that there. Now if there's an error with this, there will be a pop-up on the screen saying that there's an error. If not, we'll be able to find a new log file in our roaming directory. Now we have no error message here at all, so we should be able to go and find that now. Let's go and find that now. If we come back into our folder directory and we can just go to our roaming directory, we can see that if we come to our AppData, roaming, blank project and log, we now have a new text document created. Let's just open this quickly. You'll now be able to see that we're also correctly printing to this log file. So we've done everything that we were set out to achieve so far. This is nice and this is brilliant. This is exactly what we want. But there's one extra special little bit of an extra that I'm going to give to you guys that I think just helps me greatly with this process. For this next section, I'm barely going to even explain what we're going to do. I'm just going to show you. Let's come to our logger.h file and let's just add these extra little functions in here. Print debug separator is going to be very handy for our log file. This is going to print a line of characters with no time string. It will just help us keep things separated. The next two functions are to start and to run MTail. Now MTail is a wonderful little program that you can run alongside your project. Let's go to our logger.cpp file and let's just import some of this in here. Let's come to the bottom here and let's just import this in. As you can see, our print debug separator is just going to print this line on with a few spaces. We've got a lot of red errors up here, and that is because we need to add a couple of extra functions in to get this to work. Let's just do that now. We need to add in the CStudio and the TL helper 32.h header files. If we now come down to the bottom, we can have a look here. Now, this is running from a completely different system, so this isn't actually how it should be, but let's have a look at this. How do we change this over? Let's try this. Let's just change that for path. Just change that for path. And that should work absolutely fine. Now, if we go back to our application.cpp, this is the one for our project itself, and we go to initialize, we can just now go logger.startMTail. We need to have the MTail program active or onto our build project to be able to run it, and include inside the GitHub file you'll find this. If we come to our blank project file and you come down to the bottom, I've actually included MTail in with the build. It's just a single application with no includes, but it does give us a great benefit. Great benefit of that is that when we run this program, let's have a look at that now. Now that's not actually working correctly right now. Let's just make sure we've got all of the DLLs moved across. Build Olympus. There's our DLL. Let's put that in here as so. And there we go. That should work absolutely fine. So let's try this again now. You'll see that up in the background, we've actually opened the MTail program. This program is like a notepad document, but every time we update, it will print onto here. Let's try this in a different way. Let's use our loop function. Let's just print our loop. Let's try this again now. Let's close that. Let's close our program and let's just start this from very fresh. You'll see now that as our log is updated, it will actually update and log on the screen. This is great, and this will help us keep track of exactly what's going on with our program, both after it's closed and while it's running. Now we've got that working nicely, we can think about maybe formatting this so it's a little bit nicer to look at, and I've just made us this up. This is just going to print a few debug separators, print us the name of the game and the boot time up on the screen, and let's just get rid of this loop function. Now one thing you may notice about MTail is it's not going to reopen while it's open, so let's just... There we go. We can now see that our program is printing our log file to a separate window that we can see and monitor at all times. And this will be saved to our desktop or to our hard drive at all times so that we can access it whenever we want, and we can even compare these different log files. This is how we would get AAA games doing it, where they would save directly to the hard drive, and this puts us in a really good stead for us to continue with our programming. In this episode, we've created our log files so that we can keep track of what's going on with our program. We've also looked into experiencing new things. We've started to build up a library of different functions that we can use in our program, and I've been doing this since the day that I started programming. You'll always find a specific way to do something, and it's handy to be able to keep that with you. You'll find that your engine will end up as a complete library of 1,000 different things that you've learnt along the way. As well as this, we've looked into creating files on our AppData so that we know how we can separate what goes into our engine, our project, and what goes into the specific saves of our users. In the next episode, we're going to be looking into cleaning this all up very slightly, and then looking into the game engine framework. This is going to be a framework for our window for our game, and as well as how we're going to run our DirectX 12 windows. We need approximately one more episode before we even really start looking into DirectX 12. Even then, if we rush too quickly into DirectX 12, we are going to have to stop in the middle to input things like the inputs, the keyboard functions and the mouse functions. So I want to try and make this as best as possible for all of us. I look forward, and there's lots more to come. So I'll see you next time, where we'll be creating a C++ DirectX ready game engine.